In the following presentation, we will provide a short overview of the main modeling and detailing functionalities of Advanced Steel. Advanced Steel is part of the Graitec beam solution. It was specifically designed for structural engineers and steel detailers, being perfectly embedded in AutoCAD. Advanced Steel is an easy-to-use steel detailing software that automates the production of drawings, forms, and NC files. We will begin by creating a system of axes from 0, origin with a width of 12 meters and a length of 18 meters. In the building grid properties, we will use capital letters to designate the axes. On the group page, we will modify the number of axes. For example, we will use only 3 axes. We will create a frame with 2 slopes. We position the first and the second columns. Properties window will appear, in which we can set the roof slope in percentage. In this case, the slope will be 15 degrees. The column section will be HEA 240 and the beam section will be IPE 240. For this frame, we select the corresponding connections from the connections vault. We select the haunch on column flange connection. From the Properties window, we can modify the haunch parameters. We can create a cantilever. We can also set the parameters of the column and plate. Other elements of the connection are the bolts. For the bolts, we can select the type, the diameter, and the distance between them. We can select the thickness of the weld lines between the connection elements. We can stiffen the flange of the haunch. We position stiffeners on the lower flange of the beam and on the haunch flange of the column and the haunch flange of the beam. The next connection type that we will select from the connection vault is the apex haunch connection. As we did for the haunch on column flange connection, we can set the parameters of the haunches, the beam end plates, the bolts and the distance between them. We use the Create from Template function to create the connection between the column and the beam in the other part of the frame. Returning to the connection vault, we select the connection specific for the base plate. We set a thickness of 20 mm for the base plate. We increase the contour of the base plate by 100 mm from the column section. We display only the holes in the base plate, and we set a distance parallel to the flanges to the profile web. We can return later and add thrusts and anchor profiles. If necessary, we can also add an additional external stiffener. Next, we add stiffeners on the column web. And then on the column flange. Using the create from template function, we create the base plate for the other column. Next, we check the collisions. In the dialog window, a message appears confirming that there are no collisions. We select the frame and the connections, and we use an advanced copy function provided by Advanced Deal. We build the purlins by selecting the beams on one side of the structure. We select the Lindab Z section. Setting the distance between the purlins to 1100 mm. Using the same function, create from template, we also position the purlins on the other side of the structure and then reverse them. On the longitudinal direction, we place bracings between the columns. We select the rounded tube section. We copy the bracings between the last two columns and then use the mirror command to position the bracing on the other side of the structure. Next, we select the corresponding connection between the column, the base plate, and the bracing. We adjust the diagonal to be aligned with the base plate, and then we select a specific connection between the bracings for the middle part. We increase the middle bracing. We also create the connection for the other bracing using the copy from template function. The next connection type is the connection between the beam and the purlin through a folded profile . Using the create from template function, we also create the connection for the bracing at the upper side of the columns. The specific connection between the beam and the purlin is created along the first frame using the create from multiple template function. We can preview the structure in the solid representation using the shade function in AutoCAD. The next step is the numbering of elements in order to obtain the details and the lists. We number the parts and the structure assemblies. And then we prefix the parts and the assemblies. Then, we position the coordinate system to generate a 3D view of the structure. We select the 1 to 50 scale, the 3D view drawing name, and the A1 drawing format. We open the sheet in which we have already automatically created the 3D view. We position the WCS over the base plate to create a sheet with the column positioning. We view the sheet. We rotate the coordinate system according to the x-axis, and we generate an elevation of the first frame. On the same sheet, we add a node detail at the column base and also another detail between the column and the beam. We generate a drawing with all the structure parts. We will obtain all necessary dimensions for customizing the elements. We add a material list corresponding to this drawing. Returning to the model, we select a column and we generate an assembly drawing. Here, we will find all dimensions for positioning the attached elements and also the elements with the elements position. We add a list specific to this type of drawing. Returning to the model, we generate the material list with selected elements. We also generate NC files, text files, and graphic files. The model created in Advanced Steel can be exported to DWG files that allow to directly view the project in AutoCAD. In this presentation, we have only presented some of the main functionalities of the modeling and detailing software solution Advanced Steel. For more information, please do not hesitate to contact a Graitec representative.